Welcome to the shop. Today we're going to do something really fun. We're going to align the sliding table on my Felder sliding table saw. And I can just imagine what some of you are thinking. Oh my God! That sounds like a terrible idea. I don't ever want to have to do that. Well, I felt the same way when I first got mine, but I've been through it a few times. So I thought I'd film the whole process as a time lapse and maybe do a little voiceover if it works out, and show you what I go through when I actually do the alignment. So first thing I've done is taken the outrigger off the machine. I've got my dial indicators ready to be put to use here. I've got my 19mm wrench for adjusting the height studs, and we'll get to it. Enjoy. So this is what a 10-foot slider support system looks like on a KF 700, 900, Kappa 400. You've got 4 pairs of studs to hold the lower carriage of the sliding table, and the T-slot for the lower sliding table carriage goes between this washer and this square washer or flange above. It just slides right through that slot all the way down on all studs. So here's a 10-foot sliding table on a Felder sliding table saw. This is a Kappa 400, but the sliding tables are all the same from the 500 series upwards. So the top extrusion of the sliding table runs along a lower carriage which is attached to the machine base. This lower carriage is another aluminum extrusion, as you can see, and the bearings run in this V-shaped way system between the sliding table and the lower carriage, and that's what allows this to move back and forth freely. There are cylindrical bearings sandwiched in between there. But what I wanted to point out was how this lower carriage attaches to the bottom of the machine base here. So the machine will come with studs sticking up from the machine chassis, and the lower carriage of the sliding table has T-slots, 2 of them, and those can be threaded on between the top of the stud and the first nut that you encounter coming downwards on the stud system. So you feed it onto those studs from the infeed side of the table. There is a locking position here that you'll encounter once you get the lower carriage pushed as far forward as it will go. It will stop, and that's where you want to mount the lower carriage by bringing these nuts upward against the lower carriage of the sliding table. So these studs that go through the machine chassis give you adjustability to be able to move the sliding table up and down and change its angle relative to the cast iron top of the machine. That's the basic adjustment mechanism. The studs come in pairs. There will either be 2 pair, 3 pair, or 4 pair depending upon the length of the sliding table. The studs have nuts on the top and the bottom of the chassis, and by loosening and tightening those nuts, you can move the studs up and down and change the elevation of the sliding table and its angle relative to the cast iron top. So what you need to adjust those nuts on the studs to change the elevation and angle of the sliding table is a 19mm combination wrench. You do want a combination wrench with a 12-point spherical end like this one has and an open end at the other, because some of the nuts are difficult to get to and are restricted in terms of how you can get onto them, and you do need this end. So for instance, here I can get to the top nut on this with the open end portion, and then I've got a lot of adjustability. But here in the end, I've got really restricted capability to get in there, and I need all 12 points of the end of this wrench to be able to get onto that nut and make the adjustment that's necessary. You'll find that's true of almost all the bottom sides nuts on the machine chassis. In order to get onto them, you're going to need this end of the wrench. So let's talk about tools here for a minute. The Felder technician, if he were to commission your machine, would show up with a precision straight edge like this and a collection of feeler gauges like this. These feeler gauges are different thicknesses, and you can use these under the edge of the precision ground straight edge to figure out where you've got high spots and low spots, and if the sliding table angle is the same as matches the level of the cast iron top, etc. Precision straight edge like this is a big investment. This is a 4-foot precision straight edge, and it cost me probably $300. You don't need that good. A good alternative is a well-made contractor's level. This is a Stabila. It's made in Austria. If you look when you acquire the level at the edges here, if you see little machine swirl marks, that says that this level surface has been machined true and flat. And my experience is the good quality versions of these, either Stabila or Johnson. I think Stabila's made in Germany, Johnson's made in Austria, but they're both imports. They're very flat and straight, and they work well as a precision straight edge for this kind of thing. So the first thing you want to do when setting up the machine for sliding table adjustment is to get the machine level as you can. So I've got a 2-foot Johnson level here, and I can get this level within a few thousandths of an inch by adjusting the leveling feet that I've put on the bottom of the machine. The most important thing is that the front edge of the cast iron top, its level agrees with the back edge. Now, these machine chassis have enough flex that with 4 points of leveling feet, you should be able to get this dialed in so that this surface along here on the cast iron table is coplanar with this surface along back here. And I've got a precision machinist level that I'm going to show you next that will prove that that's pretty much the case on my machine. I'll change the camera position and bring you back. So this is my precision machinist level that I find very handy. This is not cheap. This is $1,000. I bought mine used on eBay. I don't recommend you do that unless you know exactly how to evaluate the condition of one before you buy it. But there are cheaper alternatives available from other sources. They are very handy for setting up equipment like this. So I use this to check that the front edge and the back edge of the cast iron top are both level and they agree with each other in terms of their level readings. Let's move the camera and I'll show you what I mean by that. So here I've got the level set across the front edge of the cast iron top of the machine, and you can see that it's reading level here. The divisions here tell me that over the length of this level we've got a difference of 5/10,000ths of an inch per division over 12 inches. So right now this end of the cast iron top is 5/10,000ths higher than this end. That's insignificant for this purpose. Now if I were to take this over to the back side and we let it settle down, you can see we're so close that any difference here really doesn't matter. So why is this important? Well, if you put this level on the front side of the cast iron top here and let it settle down and notice where the bubble ends up. We've got the bubble right here against that index line on the left. Then you take the level and you put it on your sliding table and you look at where it settles down here. This is going to tell you whether the sliding table is coplanar with the cast iron top of the machine. Now, the sliding table may be higher or lower, but in this case, if you'll notice, that bubble is against the same index mark on that side. This sliding table is absolutely coplanar in this position with the front edge of the cast iron top of the machine. So if you want to make the investment in a precision machinist level to level your equipment, this is the one I've got. I don't recommend you go out and spend $1,000 on a master precision level. I mean, if you want to, good for you. You are a Felder owner after all, right? Cry once. So this is a Starrett model 199Z. It's available on Amazon as well as various industrial sites. If you don't want to get into it for that much money, here would be another alternative. This is also available on Amazon. It's an AccuSize 12-inch version. And the important thing here is to look at the accuracy. So this particular level, as you can see here, has 2 10,000ths of an inch over 10 inches sensitivity. That's what you want for this kind of precision measurement. You can get it in 6, 8, or 12 inch. The 12 inch is probably most appropriate for woodworking equipment alignment. You can see here it's about $160. That's not the only choice. Brian Lamb, also a Felder owner and moderator of the Felder Owners Group, produces a lovely level that has the required accuracy and is 16 inches long. I would recommend that one as well. While we're here, Brian also makes a precision square that can be very useful in aligning your crosscut fence and other work. So I hope this helps if you're interested in making that kind of an investment. So here is a pretty common tool used for aligning the sliding tables, a dial indicator on a magnetic base. This is a pretty fancy magnetic base. This is by Noga. They're about $100. You don't need anything nearly this sophisticated. There are much less expensive versions on the market. The dial indicator here is a $10 thing from Amazon. That's perfectly sufficient for adjusting a sliding table. So first thing I'm going to do is get this dial indicator, which is indicating to the top of the cast iron table, to read 0 here. I've got a micro adjust on the back so I can actually change that. So we're reading 0 here. Now if I move this over to indicate to the sliding table, what this is telling me is that this edge of the sliding table is about 2 thousandths higher than the cast iron top of the machine. So I think you can see through the use of this, you can get some pretty accurate understanding about how the surface of the sliding table compares to the cast iron top. So most dial indicators have a lug on the back with a hole in it that you can use to attach that dial indicator to a batten like I've done here. And if you look, I've just got a stack of plywood screwed together here with a oak batten on top holding that indicator out here to the far edge. You know, easy enough to make your own. You're a woodworker, right? The only important thing here is that this be heavy so it holds it flat to the cast iron top, and that the bottom of it be absolutely dead flat. So run it across your jointer and get that thing flat, and then the rest of it really doesn't matter because you can tilt this dial indicator here on the batten to zero it out to be identical when it's on some flat surface, like say you put it across your sliding table surface here. Adjust that so it reads 0, and then when you put it back on your cast iron top, any deviation from 0 is how much different this height is from the cast iron top. So if you're okay making a little investment here in some dial indicators and magnetic bases, I'll give you a little clue what to look for. Here on Amazon is an $11 dial indicator, perfectly adequate for the job of lining sliding tables and doing pretty much anything. This particular one here has a lugged back, as you can see, so you can screw it down to a batten if you want to extend out to the far edge of the sliding table. That's about as cheap as they go, and definitely worth the investment if you're willing to make it. Now for an indicator stand, this is the kind I prefer, with kind of articulating arms that you loosen this big knob here and it turns into a flexible thing. It's got a magnetic base with an on-off switch, and then your dial indicator fits in this end of the plunger out here. And it has a micro adjust. So here's one for $25 on Amazon. Make sure if you buy one, it's got the kind of reach that you want. 14 inches would be appropriate for the edge of the sliding table closest to the cast iron top. Is not going to reach out to the far side. For that, you're going to have to make your own batten, or invest in one with a longer arm. But that'll set you back a good $100. If you wanted to buy a kit with everything included, here's one for $36.88. This has a different kind of magnetic base stand with locking levers. It's not as easy to configure and adjust, but it works, and it includes a dial indicator and several indicator points, including large buttons and small pointed things, and yeah, all kinds of things. So those would be what I would look towards if you wanted to invest in some dial indicators to get your equipment aligned. It might come in handy later for use on a shaper for tooling height adjustments and that sort of thing. Anyway, hope this helps. So before we get into the actual mechanics of adjusting the sliding table, let me first tell you where the situation stands at the moment. Last night I took the opportunity to loosen all of the mounting bolts that secure the bottom carriage of the sliding table to the actual machine chassis. There are 8 of those bolts in total. They've all been loosened for a good 18 hours, at least enough to let that bottom chassis straighten out if there were any kind of sort of memory issues associated with it. The machine has a 10-foot sliding table. We're going to get it grossly aligned in terms of height first, and then before we fine-tune all the height, we need to get the sliding table trajectory set so that the toe out is proper. We need the sliding table to drift away from the blade as it's moving forward about 0.03 of an inch or so over 8 to 10 inches. I'll go into that in a little more detail when we get to that point. I've got 3 dial indicators here on stands that I'll be using. I'll be setting that up and then getting a gross setup of the table height as a first order of business. So here we go. So here's my approach to adjusting the sliding table on a 10-foot slider like this. First thing I do is I lock the slider in its middle position. We have 8 adjustment bolts that control the height and the tilt of the sliding table. There are 2 here at the ends, there's 2 here right where the trunnion mounts, there's 2 here where the back of the trunnion mounts, and then there's 2 here at the end of the chassis. So what I generally do is I set up the table with the bolts at the two extreme ends loose, top and bottom, and I adjust the 4 bolts here in the middle of the span of the lower support rail so that I get a consistent reading for the height above the cast iron top of 5/1000ths of an inch on all 3 of these indicators. Now I know that the table in its locked middle position is level to the cast iron top or coplanar to it, and I know that it's 5/1000ths of an inch higher in that position. Now it takes some fussing around with the bolts here, and I'll get you some close-ups of that in a second, to actually get this table to the right height and level. That's the first step in the process, the way I do this. And I use 3 dial indicators here because you can see visually, if you look at the dial indicators, the interaction of twisting a bolt, what it's doing to the various surfaces of the table. So here's where we are so far. I've got the sliding table set mid-span. I haven't touched the 4 outside bolts here at all. They are still loose. I've been working on the 2 pairs of studs that control the table height and tilt here at this end of the table and over here at the front end of the cast iron top. And here's where we are so far. We are 4/1000ths above the cast iron top here. We are 5/1000ths above the cast iron top here. And we are 3.5 above the cast iron top on the outer edge. This is the little cheat sheet I made up to keep myself honest. It's pretty easy to get confused when you're working on the top side of the stud with the adjusting nut at one instance and the bottom side on the other. So for the upper nut, if I want to raise the table, I have to turn that nut clockwise. If I want to lower the table, I turn it counterclockwise. And then on the lower nut underneath the chassis, I got the same diagram going on here, so I don't forget. It's easy to get confused. You think, oh, I'm working on the bottom side, I should go the other direction. This is what keeps you honest. If you're doing this, I suggest you make one of these for yourself. So at this point, I've got the slider leveled and about where I want it vertically relative to the cast iron top, using just the 4 bolts in the center that support the lower carriage. Before I go on to make any final adjustments here and deal with the sliding table moving to its extreme ends, I want to get the table aligned to the saw blade so that as it moves forward, it drifts out slightly over the distance of the saw blade. And by slightly, I'm talking about 2 to 4/1000ths of an inch of toe out here. So I'm going to take these dial indicators off the machine now and set up another dial indicator setup so that I can actually measure the drift of the sliding table relative to the saw blade as it's moving forward. I'll put you back on time lapse and get this set up. Let's go over another important alignment for the sliding table saw, and that is the toe out of the sliding table itself. In theory, what you want here is the sliding table in any position to move slightly away from the saw blade as the table is moving forward. The rule of thumb I use is over an 8 or 10 inch distance. Here you want the sliding table to move away from the saw blade 2 to 4 thousandths of an inch, something like that. If you have it adjusted that way, then the likelihood of a kickback or the back edge of the saw blade burning the stock that you're moving through the rotating blade is much reduced. And now I'm going to take you through a common procedures for checking for toe out here. One common method talked about is to measure the distance from using a dial indicator stationary on the sliding table to a particular tooth on the blade at the front. Note that distance, move this around, and take that same reading on that same tooth at the back. A lot of people think these blades are flat and they just indicate across the flat section, the base of the blade here. That's not good practice. These blades aren't flat in that area. So you really need to look at what's going on relative to the cutting surface of the teeth. So let me show you how we would do that here. I've marked one tooth so that we know which one we're dealing with when we move the sliding table forward. So the first thing I'm going to do is get this dial indicator, which is on a one-way gauge here, which I can clamp to the sliding table, positioned so that I get a small reading on the dial indicator here on that tooth. I'm going to clamp the one-way gauge down to the sliding table so that it's stationary. Now I'm going to zero out the dial here on the dial indicator. I'll bring you in a little closer. Maybe you can see that a little better. And now what we can do is move. We've got the dial indicator 0 here against that tooth. Let's pull the indicator plunger away, move the sliding table forward, and indicate to that same tooth at this other end. And if you see that, we have a displacement there. This is telling me we've got 5 thousandths of an inch or so difference. I know it's better than that, and I'll show you how I know that. So here's a setup I use to just double check my toe out on my sliding table often. I've got a dial indicator clamped to the sliding table, and it's indicating outwards. You got to get it clamped down or this is meaningless. I've used my Polish square here to take the surface of the teeth on the saw blade and project that out in a coplanar manner out in front so you can indicate to it. And then you can check your toe out. I've got the blade raised about 40 millimeters. You could put a straight edge on this side, a contractor's level. I use this square because I know it's dead flat and it's heavy and it will stay put. If you use something lighter weight, like a straight edge or something like that, clamp it lightly to the blade, don't get carried away, so you're distorting the blade by the clamping force. So anyway, here is what I get for toe out on my sliding table. You can follow along here. I've got it zeroed out at this point. I'm going to move it forward now. And we've got about 3 thousandths, 4 thousandths of an inch. This is a pretty reliable way. It averages out all the teeth. You know, the best way to do it is with a dado cutter because that's dead flat and isn't going to flex. But this is a good way to get an average and have it projected out coplanar to the side of the blade so you can indicate to it. Hope this helps. Well, after an hour and a half maybe of working on the various height adjustment studs, I've got this thing dialed in pretty much where I want it, and it's behaving as I move the sliding table forward and backward. I'll unlock it, and you can observe the dial indicators here as I'm moving the sliding table from one end to the other. Right now it's in the center position. I'll pull it back as all the way to the infeed side. And you can see here we've got a consistent 4/1000ths here. This is reading about 5/1000ths. This is reading about 5/1000ths as well. Watch now as I move the sliding table forward, the behavior. We do get some slight variation here, but it stays in a band, each indicator of about 2/1000ths of an inch variation from one end to the other. At no point here do any of the sliding table surfaces fall below the surface of the cast iron table, which if it did would create drag and binding if the material that was being moved was clamped solidly down to the sliding table. So we're in good shape here. The toe out has been set. I'm going to re-verify that. I'll show you that in a second. But this is much tighter tolerance than a Felder technician would be shooting for, or in most cases capable of, given the tools that they're supplied with. Using the dial indicators here, I've been able to get this to within 3/1000ths variation from one end of the slide to the other. You know, the Felder spec for quote good is 10/1000ths of an inch. So I'm pretty happy with the results here, and to be quite honest with you, I probably couldn't have done it without the dial indicator setup. If I was stuck to using a precision straight edge and feeler gauges, I might be able to get here, but it would have taken 20 hours or more. I have spent that, trust me. I'd like to show you one common misconception about how to go about adjusting the sliding table. The point here is that when you're adjusting the sliding table, you have to be conscious of where the bearing cage is between the lower carriage and the sliding table itself. Because the studs that are under where the bearing cage is are what's going to drive the sliding table up or down, or change the angle of it. If you'll look here closely at the dial indicators on the infeed and outfeed end of the cast iron top, you'll see they're both reading high. What I'm going to do now, because the sliding table is pulled towards the infeed side, the bearing cage is sitting right about here. So the adjustment for these is not down here to get this one to change, it's over here. So I'm going to zoom you back in, and I'm going to start working on the adjustment stud right here at the end, the very last one on the outside, and watch what happens to these two indicators here. So what I'm doing is loosening the bottom nut on this stud so that the stud moves upwards. And as I do that, I think you can see that both of those indicators are coming down to closer to our target of 5/1000ths of an inch. I'm going to tighten the upper nut now since I've moved the lower nut, and there we are, we're back in position. Let's move the sliding table to the center of its range and double check that we haven't affected things there. We're still showing on the infeed and the outfeed side that the sliding table is indeed 5/1000ths of an inch above the cast iron top in both locations. So we're good there. And that adjustment to pull that down actually helped a lot. Interpretation of this same concept about how to adjust the extreme ends of the sliding table. Here we have the machine chassis shown in green, attaching the lower carriage of the sliding table system to the machine chassis with 4 pairs of adjustment bolts, 1, 2, 3, 4 here in the center, and 5, 6, 7, 8 at the extreme ends. So if when the sliding table is pulled all the way to the extreme infeed end, and this section of the sliding table shown here with the dial indicator is going wild on you, the adjustment for that is not here at this end, which is what you would normally think. It's over here at the opposite end of where you're reading. And that's because the bearing cage is sitting over or between the adjustment studs at this end of the lower carriage. And it's that bearing cage is telegraphing the position of the lower carriage to the upper carriage here. So if you want to adjust this end, it's done here with these studs. Similarly, if the sliding table is projected all the way forward to the outfeed side, and you're getting wild variations here, the adjustment for that is at the opposite end of the lower carriage of the sliding table. Now, don't expect to get the extreme ends of this to behave within less than 10/1000ths of an inch variation from nominal. You can maybe get it there, but it isn't really necessary, first of all, and you can drive yourself crazy chasing your trail trying to get this dialed in. You'll adjust this, and then you'll discover the other end is going wild, and then you'll adjust that, and back and forth. You can get it into a 5/1000ths variation, but it takes a lot of time, and just beware. It may not be worth it to you to put all that time in, because it can get very frustrating. I know, because I've done it many times. Anyway, I hope this clarifies that relationship between where the adjustment studs are and your measurement point. So to check the squareness of the crosscut fence to the travel of the sliding table, I've set up my dial indicator here on a magnetic base attached to the cast iron top of the machine. I've got the dial indicator shaft coming out over the sliding table. I've got my precision machinist square here, which I'm going to move over against that dial indicator until we get some displacement there. And now I think if you watch closely, I'll zoom you in, as I move the sliding table back and forth, I have no change in the dial indicator reading. Back and forth. That tells me this crosscut fence is square to the travel of the sliding table. Well, I know this has been a long video. Appreciate your patience if you've gotten all the way through to the end here. I really hope this is helpful. I appreciate you watching. Feel free to leave comments or subscribe to my channel if you'd like. And good luck in your pursuits of lining your sliding tables. Thanks for watching.